So we have introduced the concept of limit. How we have introduced? We have started from a sequence, okay, and we are writing like this: n tends to infinity, a n suppose is equal to L. I'm writing like this. What do you mean by this? That means when I'm writing A1, A2, A3 like this, AN, n plus 1 like this. So after infinite number of terms, the AN is becoming just like L. I can like L, L, L. Okay? Are you getting? So after some times, the term of the sequence is behaving like a number L. So that means I can say that the sequence converts to L like this. Suppose I am writing an equal to 1 by n. So then my set of all terms of the sequence is a1. That is a1 is here. It is 1, then 1 by 2, then 1 by 3, then 1 by 4, 1 by 5 like this. Suppose you are writing 1 by 50,000. So it is almost equal to 0. And similarly, if you write the other term 5001, so it is also almost equal to 0. So that means after many terms, you are having the element of the sequence as 0. So that's why I'm saying that this sequence is converging to 0. Okay. If the sequence is converging to L, then after some time, all the terms of the sequence will be very nearer to L. Okay, so this is the concept of limit of a sequence. Okay, and here what is the restriction? Here I am just taking an as means my variable n. N is here variable. I am putting n something. Suppose here an is equal to 1 by n. Whenever I am writing limit n tends to infinity 1 by n, then n is behaving like a variable. I am setting n is equal to 1, setting n is equal to 2, setting n is equal to 3 like this. And I am not taking n equal to 1 by 2. I am not taking n is equal to 1 by 3, n is equal to 1 by 4. So that means what is here, what is the restriction? Here, restriction is I am only taking this n from the set of natural number. Okay? Are you ready? So I am only taking n from the natural number. If I will take n from the real number, then I am talking about some general concept. Okay? So in that case, what is my target? Here, generally we are writing, instead of whenever I am allowed to take any real number, we replace n by x. So that means I am writing f of x. Suppose instead of n going to infinite, suppose ex goes to a. Okay. And here the variable is x going to something. So x is the variable. And here I can take any x. I can take any x like this. So x belongs to R. R means real number. Okay. So whenever f of x is equal to 1 by x, okay, and a is equal to 0 say, okay, so let us study the behavior of this limit. Okay, so f of x is equal to 1 by x, and x is, that means x is going to 0. So I am writing like this as, in particular I am writing this as x going to 0 Your f of x is 1 by x. And what is the difference between these types of thing and these types of thing? Here you can see that here n is the variable and here x is the variable. And here n belongs to capital N, that means set of all natural number, but here x belongs to R. Are you getting this is the difference? So that means in the collection of 1 by x, I can have these types of number 1 by 1.5, 1 by 1.6, 1 by 1.7 like this. These types of numbers are allowed here. Are you getting? But here you are not allowed to take 1 by 1 minus 1 by 1.5 like this. Okay, this is the main difference. Okay. So if you are taking x value continuously, that means x value lies in the set of real number, the graphical interpretation of limit we can do. Okay. So now in this class I will discuss about the graphical meaning of a limit or graphical interpretation of a limit. You can write, or you can write geometrical viewpoint of limit of a function at a point. What do you mean by this? Are you getting or not? So that means here the function is 1 by x, here the point is 0. So I am talking about the limit of a function which is like this for x approaching to 0. Why I am interested to do such limit? Because when I am putting x is equal to 0, its value is undefined. 1 by 0 is undefined. But can I do some approximation of the function when x approaches to 0? I see you cannot find 1 by 0, but you can find always 1.0.001. You can always find 1 by 1 or 1 by this is or minus 0.001. This types of thing you can do always. But 1 by 0 is not defined. If you are setting input nearer to 0, then it is defined. But for exact value 0, it is undefined. So that means limit may exist, or a limit limit evaluation of the limit has some meaning. So let us do what it represents. And in the previous class, we have also discussed this fact: if LHL is equal to RHL, then limit exists. So geometrically, try to first of all analyze its domain. X is approaching to 0. So in the real line, so this is your 0, and I may approach 0 from this side, or I may approach 0 from this side. Okay. Whenever I am approaching 0 from this side, its value is, or we say that we are evaluating right hand limit, and for this case it is left hand limit. Okay. So we are writing in this manner, and before doing that, we should plot the graph of 1 by x. So how it is behaving when x is approaching to 0. So it is just like this. When x is approaching to 0, its value is like this, and when x is approaching 0 from other side, its graph is like this. You draw this graph. So this is the graph of 1 by x. How I am plotting? I am taking y is equal to 1 by x, and I am doing a table. Suppose this is my x value, this is my y value. Okay. So I am taking different value for x. Suppose x is equal to 1, y will be 1. Okay. x is equal to 1, it is 1 with 1. So similarly, when x is becoming infinite, if x is becoming infinite, it is becoming 0. 1 by okay, it is nearer to 0, it is not exactly 0. That means this line is asymptote, this is an asymptote. Approaching this line. The graph is not meeting this line, rather it is only always approaching this line. So that means this x axis.
सर वीडियो आसुनी
सर आपनको वीडियो आसुने
ଟିକେ wait kar ago.
तो किछि देखे जाउनी
Just wait for a while, it will come. So now this is the graph of 1 by x. So if you would take 0.5, if you take 0. minus 5, 0, minus 0.5 like this, you take different values for x, correspondingly you evaluate the value of y, then you will plot.
सर वीडियो आसु नहीं
Sorry.
सर वीडियो ऑफ कर दी जल्दी
ମୁଁ
आगे सर
ନାଇଁ ଅଫ୍ କରିନି.
आसु नहीं सर
Is it okay now?
नो सर
ना सर आसुनी
नो सर किछि देसु नहीं
Yes.
ना सर किसी आसु
तो किछि देसु नहीं
नो सर ना
Is it okay now?
सर
ब्लर सर
असला
Asila.
असला सर असला
Okay. So see, so this is the point 0. See, whenever I am approaching in this direction, okay, its value is going towards infinity, and when I am approaching from this direction, its value is going to minus infinity. So I can write this types of thing here. So from the graph itself, I can say that whether limit will exist or not. Okay, and limit will exist means you may approach from this side or from this side. The value should be same. That means LHL should be equal to RHL. Okay, and here when I am approaching from this side, its value is becoming infinite. When I am approaching from this side to 0, its value is becoming minus infinite. So mathematically, what can I write? Limit x tends to 0. So whenever you are approaching from the positive side, generally from the right hand side, if I am approaching from the right hand side, it is treated as the positive side. So here I am writing like this. So its value will be, yes, I am approaching this side, so its value is infinite. Okay, and if I am writing x tends to 0 minus means I am approaching from this side. Its value is 1 by x is equal to minus. So this is your RHL and this is your LHL. Okay. So clearly RHL is not equal to LHL. So therefore limit does not exist. Are you getting? If I will have this types of graph, whether limit will exist or not, yes. So instead of this, if I am having a graph this as well as this, then you can see that whenever you are approaching from this side, its value is infinite, and whenever you are approaching from this side, its value is also infinite. Generally, whenever we are taking taking the value of the limit, that means if the LHL and RHL are equal, then limit exists. We can say that limit exists in some sense. It should be a finite quantity, but here it is not becoming a finite quantity. It is becoming infinite quantity. But as LHL and RHL are both same, so I can say that limit exists, but its value is infinite. So here I can say that for this case, actually, if I am doing like this, the function will be like this. F of x will be module of x by x. No, sorry. So it's actually it will be 1 by modulus of x. Okay. So this is the graph. This is the graph for this dotted line. Along with this graph, along with this graph, is the graph of f of x is equal to 1 by x. And I can say that when limit x tends to 0 minus it is equal to infinite, and also when limit x tends to 0 plus 1 by x is also infinite. Okay, because whenever I'm moving from this direction, its value is going to infinite. Whenever I'm moving in this direction, its value is infinite. So here I can say that limit exists, but its value is infinite. Okay. So this type of limit is called infinite limit. This is called infinite limit because it is not giving a finite quantity. But as LHL is equal to RHL, in some sense, in what sense? It is existing, but its value is infinite. So this is a particular type of limit. This is called infinite limit. I have discussed two things. One is infinite limit, another is limit at infinite. What do you mean by limit at infinite? Whenever I am writing like this, limit x tends to infinite.
सर वीडियो टा कटियाला
Yes. Suppose I am writing, just wait. Suppose I am writing limit x tends to infinite 1 by x. So this type of limit is called limit at infinite. At the point infinity, I am interested to find. Yes. It is not clear. So just wait for a while. So this types of limit is called, if this is the situation, this is called infinite limit. If this is if you are evaluating this type
सर वीडियो टा आसुनी
okay. So let us rejoin. Okay. Is it clear? See? Yes.
No, sir.
नो सर
No.
No, sir.
नो
Okay. Just wait. So we are discussing just listen something. So we are discussing two things. One is limit at infinite. Another is infinite limit. That means if
ना सर आसुनी वीडियो टा
so I'm not writing anything. Just listen. Let us wait for a while. So it will come. So see, we are discussing two concepts. One is limit at infinite. That means at the point infinite, I want to evaluate the limit. It is called limit at infinite. If the value of the limit is infinite, actually in general we are saying that limit should not exist. But we are giving another name to that. I am saying that if the value of the limit is infinite, then it is called infinite limit. So when limit will exist, if LHL is equal to RHL, then limit will exist. If it is a finite quantity, this is the normal limit. Okay? And if it is becoming an infinite quantity, so in general, we should not say that limit exists, but we are giving some other name to that, that is called infinite limit. That means limit is infinite. Limit is not evaluated at infinite. Limit is here, you can say that here we are evaluating the limit at 0 because x tends to 0. We are evaluating limit at 0, but its value is becoming infinite. So it is called infinite limit. Okay? So these two concepts we should understand. Okay. Now my next question is, so we have evaluated the left hand limit and right hand limit from the geometry. But how we can evaluate limit LHL and RHL in analytic point of view. Okay, in analytic point of view means what? You have to evaluate the limit by some computation. Okay, so you may write algorithm to find LHL and RHL. To find LHL and RHL. Left hand limit and right hand limit. So, right, we are defining like this. Whenever I am writing limit x tends to a minus, what do you mean by this? What do you mean by this? So you may do like this. So suppose a is here. So you are approaching a from this side. So that means the x will be here. Okay? And we are writing like this. We are little left to a. So that's why we can, how much little? Suppose I am left to a with a distance h. Okay? Which is a small thing, small quantity, small positive quantity. So I may write h tends to 0 f of, I am little away from a in the direction left. So that means I can write it is a minus h. Okay? And here h is a positive thing. So this thing is same as this thing. Are you understanding? Here I am.
Sir, ସେଟା ଆଉ ଥରେ କୁହନ୍ତୁ।
Yes.
Sir, ସେଟା ବୁଝି ଆସିଲାନି, ଆଉ ଥରେ ଟିକେ କୁହନ୍ତୁ।
So see, whenever I am writing limit x tends to a minus f of x, geometrically it says that you are placing your x left to a, little left to a. How much little? I have to specify. Suppose I am specifying that little quantity as h, a positive quantity. Suppose I am placing this x little away from a, but I can say a little away from a, left to a. So that means I should write x instead of x. I can write, if I am writing like this, so it specifies that your x is left to a. Are you getting? You are writing a minus x, so it will be left to a. Okay.
Okay, sir.
So that means here there is no question of plus or minus. You can directly evaluate this limit. It is easy. Okay. And similarly, if I am interested to find the RHL, so geometrically, so its meaning is your A is here, so x is approaching from the right. So you may write like this, and where is x? So x is here. So this thing can be written as limit h tends to 0. H means small quantity, I am specifying. So this x will be little away from a, away from a. So I may write a plus x. So you evaluate this limit and you evaluate this limit. Okay. So let us do one example so that you will be clear. Are you understanding? Whenever you are evaluating LHL, so you write like this. Whenever you are evaluating RHL, you write like this. The question is, let f of x equal to 5x minus 4 if x is lying in this interval and its value is 4x cubed minus 3x if x is lying between this. Let us, and the question is show that
सर क्वेश्चन टा पूरा देखा जाऊनी
देखा जाओ नहीं so that limit x tends to 1.
पूरा
1 minute. Exists. So, yes. Is it clear? So let me read.
no sir.
F of x is equal to 5x minus 4 when x lies in the interval 0 to 1, and 4x cube minus 3x when x is lying in the interval 1 to 2. Here 1 is closed. Okay, so you have to show that the limit exists. Limit exists means what? At the point 1, your left hand limit must coincide with the right hand. Try to do the geometry of the domain. Geometry of the domain. So that means you have to evaluate the limit at 1. So you identify the point 1. So this is the point 1. So for LHL, you have to approach from this direction, and for RHS, you have to approach from this direction. Okay? So let us evaluate your LHL solution. To show, what to show? To show LHL should be equal to RHL. This is my target. Okay? So we should move according to the target. So now, I'm going here. LHL. So you should write like this. Your x is approaching to, for LHL, the sign is minus here. Put a sign minus here. So you write f of x. So according to the definition, what can I write? Limit x tends to 0. You have to move little away from 1 in the left side. So you should write f of what? 1 minus h. Is it okay? Left to 1, a minus h. Okay? Let us evaluate. Simplify this. So you should write this is equal to limit h tends to 0. What is your f? F is here. So first of all, you have to decide which part I should take. If x is lying here, variable is 1 minus h. So 1 minus h is a quantity lying in this interval or in this interval. So it is 1 minus h. H is a positive quantity. H is not negative. If h is negative, it may go away from 1 in the right hand side. But it is, as it is positive, you are subtracting some positive number from a. So that means it will be less than 1. So that means you have to take this function. Okay? And here the argument is 1 minus h, and the function is defined for x. So for 1 minus h, it will be what is that? So 5 into 1 minus h minus 4. Is it okay? Okay. So when h tends to 0, you can directly put h here. Why it is so? If I'm having some undefined thing, then I have to consider the limit. As it is a definite thing, so there is no problem in putting h is equal to 0. So if h is equal to 0, this is 5 minus 4, its value is 1. Okay? So this is your LHL. And what is your RHL? For RHL, you have to evaluate x tends to 1 plus. Again, you write f of x, and which is equal to limit, because whenever you are writing x tends to 1 plus, you cannot do anything because this is just a notation. You have to write in a concrete form. For that, I am introducing a variable h. So it is becoming f of here 1 plus h. So argument is 1 plus h. So that means the argument is in this interval. Are you ready? You are adding something to 1. So that means your argument, that means the argument x is lying here. Okay. So its value will be limit h tends to 0 you put 1 minus h here. So 4, 1 plus h cube minus 3 into 1 plus h. Is it okay? And this is a polynomial type of thing. So you can easily or you can directly set h is equal to 0. Okay. So if you are putting h is equal to 0, this is becoming, this is 1, this is also 1, 3. So it is equal with 4 minus.
Sir, last line दिसून
Okay. So this is 4 minus 3 again 1. Okay. So you can see that LHL is same as RHL. So you write clearly LHL is equal to RHL, therefore limit exists. So this types of problem you can always do. Okay. So this is the analytic interpretation of the concept of left hand limit and right hand. Okay. I think this is about your limit, and I will give you some formula of limits of a very particular functions which is used in our subsequent classes, which is going to be used. Okay. So the first formula, right? List of sub formula. I'm listing some limiting formula. You have to remember this, and you have to use this formula. So if the function is like this value will be n into a to the power n minus 1. And here you can say that your x is greater than 0 and a is greater than 0. Okay, and x as well as a belongs to R, any real number. So basing on this, you can solve this type of problem. Suppose you have to find the limit x tends to 2, x to the power 3 minus 8 divided by x to the power 5 minus 32. How can I do? Yes, try of your own. I am filling the ink. How we are doing? So this 2 can be written as 8 can be written as 2 to the power 3. So it is x to the power 3 minus 2 to the power 3. So n is equal to 3 here. So then you need what? X minus 2. So you may write x minus 2 here. Okay. So to use this formula you need x minus 2 here. X minus 2. And this is 2. So that means you are writing x is cube minus 2 cube by x minus 2. Again, for this, you are writing x to the power 5 minus, you can write 2 to the power 5 here. And here also you are needing x minus 2 because it should be x minus a. So it is x minus 2. So this expression can always be written like this. So under limit, you can use the properties of limit. So limit of this will be limit of this divided by limit of this. Okay. But the limit of the denominator should not be equal to 0. And in this case, it is also not equal to 0. You can check. And what should be the limit? So here x tends to 2, and here limit x tends to 2. You try to use this formula. Here n is equal to 3. Here a is equal to 2. And here n is equal to 5, or a is equal to 2. So just do. Okay.
Sir, answer 3 by 8.
Yes.
Sir, answer 3 by 8.
3 by 8. I have not done. So any other people? What is your answer?
So 3 by 20.
3 by 20.
3 by 20. Yes,
So
sir.
discuss among yourself first. So at that time I will fill up the link.
So 3 by 8 is correct or wrong?
I have
So
not
3 by 20.
I
So
have
3 by,
exactly completed that
so
part.
3 by
Sir,
20.
3 by 20.
3 by 20.
Yes, sir.
Yes,
3
sir.
by 20.
So how
Yes,
many
sir.
you are getting 3 by 20?
Sir,
Yes, now I am okay. Okay. So what should be its limit? Yes, tell me. So it is n. N is equal to
3 by
n
20.
3. Then a is equal to 2. Then n is equal to 3 means 2 means 3 minus 1 it is 2. And the denominator, so n is equal to 5. This is 5. Then 2 to the power 5 minus 1 it is 4. So you just do the calculation. So what is its value?
3 by 20, sir.
Ketala?
So 3 by 20.
Five into 16. So it is 3 by 20. You can check. Okay.
Yes, sir.
So as an homework, you can take one example. As an homework. So homework. Evaluate limit x tends to 2. Okay, x tends to 2. X to the power 2 minus 1 by 4 divided by x minus 2. Okay, you do this. Okay, this is your homework. Now, similarly, there are some common formula regarding limit. Let us list them. So, if you are writing like this, its value is e. E is the irrational number. Irrational number. It is irrational number. And similarly, whenever we are writing limit x tends to 0, 1 by x, its value is also e. And another useful formula is limit x tends to 0 log base a 1 plus x by x is equal to 1 by ln. Here base is a, but whenever I am writing ln, its base is e. Its value is e. So here a is always greater than j. Okay. So as a corollary to this, I can always have this formula. Limit x tends to 0, a to the power x minus 1 divided by x is equal to ln a.
सर
And here
ऊपर देखा जाऊनी किछि सर देखा जाऊनी सर ऊपर किछि देखा जाऊनी
0, okay. This one, limit x tends to 0, a to the power x minus 1 by x is equal to ln a. And here a should be a positive
सर
number.
वीडियो ही देखा जाऊनी
Which one?
सर अब हाँ पे वीडियो देखा वाला
Just wait.
हाँ सर
सर फोन नंबर देखा जाओनी
Which one?
4
4. Yes. For 4 I have to adjust. Limit x tends to 0 log 1 plus x with base a divided by x is equal to 1 by ln a. Ln means it is a logarithm with base e. Okay. So I will give you some questions. basing on these formulas. Okay. So I will send the material. Okay. And if you will face some problem, you can contact me through WhatsApp or by any means. Okay. So this is all about your limit. So little bit I've covered. So, but because actually the concept of limit needs more class also. So it is difficult to cover up all the concepts of limit within this short span. So anyway, we have covered the basic things. Now we'll discuss about differentiation. So from the geometrical point of view, we'll start. Suppose I have a function. What is given? Let y equal to f of x and x belongs to R. Okay? Okay. So 1 minute. And f is continuous. F should be continuous. Okay? So I have not discussed about the continuous function. Just give me some time. So continuous function. You can write f, a function f is continuous at a if limit x tends to a, f of x first bit exists. Second bit, limit x tends to a, f of x is equal to f of a. That means if functional value at a is equal to the limiting value at a, then I will say that the function is continuous. Geometrically, what do you mean by continuous function? Geometrically, it says that you can plot this graph without lifting the plane. So this is a continuous graph. Suppose the graph is like this. Suppose this is the graph, then this is the graph. So you are plotting this section in this way, then you have to lift the pen and then plot. So at this point, there is a discontinuity. Okay? At this point, there is a discontinuity. Are you ready? So continuous means without lifting your pen, without lifting the pen, you can draw the graph. Then you can say that the respective function is continuous function. If the graph is like this is the graph, and then this is, okay, then the graph is called discontinuous. So suppose, as an example, I will give, suppose I am defining a function. This is a very useful function in electronics. This is called signum function. Okay, this is called signum function. Now, how I am defining? I'm defining signum function as, so it has three parts. If x is greater than 0, okay, if x is greater than 0, its value is 1, and if x is equal to 0, its value is 0, okay, and if x is less than 0, its value is -1. Okay, let us plot this graph. When x is equal to 0, its value is 0. Okay. When x is more than 0, suppose x is equal to 1, so its value will be here. X is equal to 2, its value will be here. That means this is the one distance. See, if this is 1. So similarly, if it is if the value of x is little little more than 0, so then I can say that the graph will be 1. The functional value will be 1. So if I will plot all the images, So the graph will be like this. At 0 it is 0, so it is not there. So this is not there. So this will be the graph. And similarly, when x is less than 0, suppose I am putting x is equal to -1, its value will be -1. X is -2, its value is also -1. So its value will be. Okay. So you can observe that if you will consider this, so to plot this graph, you suppose you have started from here. You have started from here like this. Then you have to identify this point because this is a part of the graph. So how can I reach this? So you have to lift the pen. Similarly, for this section, you have to lift the pen. So this is not going to be a continuous function. Okay. And you can see that at 0, when you are approaching from this side, that means whenever you are writing f of 0 plus x, you have to use this formula. Its value is 1. Whenever you are writing f of 0 minus h, its value is, if little away from this 0 minus h, its value is 1. So I can say that here limit will not exist. Here limit will not exist. And also the functional value is at 0, functional value is 0. And functional value is 0 and limiting value does not exist. That means it is not coinciding with LHL or coinciding with RHL. So that means here the limit does not exist, as well as limit value, that means LHL is not equal to the functional value or RHL is not equal to the functional. Suppose I am defining like this. Suppose I am avoiding this section. Suppose I am avoiding this section. Okay. Suppose this is the case. So here what can I write? Here there is no question of RHL. So at the point 0, your RHL exists. So you can only approach 0 from this side. Are you ready? Because the function is not defined for negative x. The function is defined for 0 and positive x. So that means I can say that at 0 limit exists. Here limit means only one thing. That means here there is no question of LHL. There is only the concept of RHL at the point 0. Okay. So that means here I can say that limit exists, but the limit is 1. Are you ready? So a limit will be 1. For RHL it will be 1. Okay. But its functional value is 0. So here I can say that limit exists, but which is not equal to the functional value. That's why it is not continuous. Okay. Previously it was not continuous. Why? Because limit does not exist. The first bit is limit should exist and it should be equal to the functional value. Okay. So I have discussed everything. So this is the concept of limit. Concept of continuous. As an example, you should draw to like this. Suppose I am writing f of x is equal to sine x by x. Okay. And x is equal to 0, x not equal to 0 if it is like this, and 1 if x is equal to 0. Let us check whether it is continuous or not. Here, the point to check continuity is 0. Okay, because at a 0 there is a deflection or there is something changes. At a 0 it is 1 and at
सर पूरा ये बोर्ड दिखाओ ने.
Just wait. So when x is equal to 0,
टिक
so
के साइड पर
its value
अब
is 0.
क्या टिके.
Okay, so what I have to do? So solution to show f is continuous. F is continuous at 0. To show. This is to show. That is, we have to check limit x tends to 0. F of x. What is your f of x? F of x should be equal to f of a. And what is f of 0? F of 0. What is f of 0? When x is equal to 0, its value is 1. So f of 0 will be 1. That means I have to check whether limit x tends to 0 f of x is 1 or not. Okay? And now limit, you know this, x tends to 0 sin x by x. So you are remembering this as one. Is not it? In the previous class, I have given this formula.
স্যার ଟିକେ ତଳକୁ করুন স্যার ଟିକେ ফোনটা ତଳକୁ করুন
Limit x tends to 0 sin x by x is equal to 1. Okay? So which is equal to f of 0. So that means limit value is coinciding with the function value. Okay? Suppose I am changing this question. Next question. Question number 2. Suppose here I am writing 2. Okay, I'm just writing 2. Now see whether limit will, that means the function will be continuous or not. Yes. For this case, what I have to do? I just put 2 here. So now limit x tends to 0, this thing, sin x so this will be 1 by 2. This is x. Okay. And
सर से जो x जोटा लिखी दिले से पूर्व प्रीवियस क्वेश्चन टा सेटा को एग्जिस्ट कर
yes, tell me.
सर से जो x लिखी दिले प्रीवियस क्वेश्चन में sin x by x
Hello?
सेटा कोडा सेटा लिखे दिले जे
এটা আউট কোশ্চেন
तो सेटा लास्ट लाइन टा कोन टिके कोन लिखि दिले
so I will send you the video recording. Okay,
I guess sir.
so this is limit. So I can write half, then limit x tends to 0. So its value is 1. Sin x
স্যার
by
ভিডিও
x.
আসুন স্যার
So it is equal to half. And for function value,
স্যার ভিডিও আসুনি
f of 0 is 1. So half is not equal to 1. So that means limit will not, the limit will actually, the limit will exist, but it will not be continuous. Suppose instead of writing 2 here, suppose I am writing 2 here. Now check the continuity. Yes. That means you have to evaluate limit x tends
স্যার
to
ভিডিও
0.
सर এটা কন্টিনিউয়াস হবে কি ডিসকন্টিনিউয়াস
It will not be continuous because limit value is becoming 1 by 2 and function value is becoming 1. Okay, and here also you see limit 2x by x. If this limit is becoming 1, then it will be continuous. Let us evaluate this limit. So you have to use this formula. Sin theta by theta.
স্যার ঠিক আবার আসুন দেখি ভিডিও শুনি
Because here 2x is there.
সরি ভিডিও শুনে
আসুন
So you like 2x.
শুনে ভিডিও শুনে सर ऑडिबल होनी
This is 2.
ऑडिबल
So 2 get cancelled.
Yes.
So this is same expression. X tends to 0. And it is becoming twice into limit 0 sin 2x by 2x. As x tends to 0, 2x will tends to 0. So that's why its value will be 1. So this value will be 1. So the limiting value will be 2. And which is again not equal to f of 0. Is that it? So this is also not continuous.
सर बुझियला ने
Yes, I will do that. Next.
सर बुझियला ने এটা
1 minute. Suppose the question is like this: sin 2x by x. So you have to find the limit of this function at x is equal to 0. So limit x tends to 0, sin 2x by x I have to use this formula. So keeping this in our mind, I will write. Suppose this is your 2x. If I am writing 2x here, then I can use this formula. Because
सर
whenever
टिके कैमरा साइड से फूल देखा जाऊनी हाँ था हे गला सर
so देखो. So if this sign, if theta is equal to 2x, so in denominator that should be 2x. It is x, but I can write 2x. Whenever I am writing 2x, I have to multiply 2 because 2 get cancelled. So then the value will be same. Okay. So I am taking 2 out. Then it is becoming sine 2x by 2x. So its value will be 1 according to this formula. So it is 2 into 1, the whole total, it is becoming 2. But functional value, that means whenever you are evaluating the function at 0, you are saying that when x is equal to 0, its value is to be taken as 1. So it is 1. So f of 0 is equal to 1, which is not equal to 2. So it is not continuous. Okay. So now we can start the concept of differentiation. So what is given? Given y is equal to f of x. Okay. And suppose it is continuous at a or at a. It is continuous at a point A. Continuous means you are plotting like this. Okay. Suppose the point A is here. So A is here. So this is your F. And this is the point. Suppose I am naming this as P. Okay. This is your this value will be f of P. So this is your F. This is f of P. Okay. Now suppose I am taking a point Q here. I can take Q. Q is a point near to P. Near to P means it can be here or it can be here, and it should be on the curve. Suppose it is like this. It may be here or it may be here. So my ultimate aim is to find the tangent at P. Okay. The tangent at P means, so here, suppose I am moving here and here moving. I may choose Q in this direction. I may choose Q in this direction. Suppose I am moving right to A with a distance h to identify this point A plus h. And again, I may have Q here. At a time, I am taking Q this side or this side. So there is two chances. I can have Q in this side or Q in this side. Suppose Q is here, so that means this point will be A minus h. Are you ready? A minus h. So what should be its value? What should be its value? So its value will be this thing. This thing will be, so this is A plus h. So this function, this will be A evaluated at A plus h. And this will be F evaluated at A. And this point will be, suppose I am writing Q prime. Okay. If you are getting confused, I am just writing Q prime. So this is becoming F of A minus h. Okay. Actually, what is the slope then? Suppose this is the point, this is the point. You have to find the slope at A. What do you mean by this? Slope at A means F evaluated at means change in x coordinate by change in y coordinate. We are writing A plus h minus f of A divided by this h. Are you ready? H y, but change in x coordinate. Change in x coordinate is A plus h minus A. Isn't it? So A get cancelled. This is h. So this is equal to f of A plus h minus f of A divided by h. Okay. And this is the slope. This is the concept of slope, you know. Slope of what? Slope of the line, this line. Okay. And what is my target? Slope of this line slope of the line containing PQ will be like this. Suppose H is approaching 0. So H is approaching 0. H is a very small quantity. So that means that Q will approach here. So at that time, this PQ line segment will be a tangent at this. Are you ready? If H tends to 0, that means your Q will be very nearer to P. Then this line will be a tangent at P. Okay. That means this thing can occur in two different ways. If you are having Q in this side, are you ready? This thing. So here, how can I compute this? So it will be this by this. Okay. So this will be like this. Okay. So this will be f of a minus f of a minus h divided by h. This thing. Because this thing is bigger, so this thing is smaller, I can say. So this is f of a minus f of a minus h divided by what? That will be a minus a minus h or a plus h. Okay, this thing. Are you getting? So this thing can be also written as f of a minus h minus f of a divided by minus h. So just remember, I am defining the concept of tangent in two different ways. I am considering all the possibilities of the position of Q. Q is what? Q is a point very nearer to P. Here Q may be left to P or Q may be right to P. Okay. Accordingly, I am defining two things. Okay. And in each case, when H is going to 0, here also when H is going to 0, that means this Q prime or Q dash is approaching P, and here also Q will approach P. In both the cases, there will be a tangent. That means PQ or PQ prime is becoming tangent at P. Are you getting? Are you getting or not? So if H is approaching 0, that means Q approaches to P, and here Q dash approaches to P. And there will be unique, tangent should be unique. Are you getting? Tangent should be unique at a point P. So that means this thing will be here and this thing will be here. So are you getting or not? This PQ dash will lie on this tangent. Similarly, PQ will lie on this dash, on this. If this is occurring, then I can say that I am defining a valid tangent. Okay? In that case, I will say that the function is differentiable at a point P, at a point A. Okay? And the derivative of the function at the point A is nothing but it will be the slope of the tangent at P. Okay? And I am representing this quantity as, this is as R HD, right hand derivative, and I am defining this as left hand derivative. Are you ready? I am introducing two concepts. One is,
Sir, दिसून
which one? So try to understand carefully. Okay, this is very conceptual. Some people must have read these types of thing, but why they are introducing RSD or LSD, it is not clear yet. But I'm clear. Okay, and you cannot find any these types of thing in a book in this manner. Okay, so So this is RSD. RSD I'm defining like this. In your book, you will find like this. RSD, just remember that RSD like this, and just remember that LSD like this. Why it is defined like this, I have explained. Okay? Because tangent should be unique. So and Q, so that means the position of Q, that is two chance. So it may be here, it may be here, or it may be here. According to that, if it is here, I'm defining a quantity for the slope of the tangent. This is your RSD, and for this case, I'm defining another quantity. This is called LSD. Okay. Now, for the sake of computation, I will give you some formula like this. So how I'm defining? So are you understanding everything or not? This is your RSD and this is your LSD. Let me write in a clear manner. So from the observation, I could identify that these two things are representing same thing, slope of a line, the slope of a tangent at this. Okay. So what do you mean by differences? So f is differentiable at A if RHD left hand derivative, which is defined as, this is the sign for defined, equal to with this limit h tends to 0, h is a positive quantity, f of a plus h minus f of a divided by h. H is what? H is a plus h minus a. Actually, change in y coordinate. Are you getting? Change in y coordinate by change in x coordinate. So the points are a plus h and a. So you are getting like this. Okay. So in the limiting case, it is representing the slope of a tangent. That means when h tends to 0, your p and q coincides each other. Okay. At that time, there will be no question of PQ separate line segment. It will be a tangent at P. Okay. And this is defined for LSD. Differential derivative, that is which is equal to LHD, and which is, you write equal to sign here, and LHD defined, I am not going to define, and if it is coinciding with this quantity h tends to 0, f of a minus h minus f of a divided by minus h. I'm just writing like this. Okay. Is it okay? So if these two things are same, then I can say that the f is differentiable at the point A. Okay. So differentiation is nothing but a reduction of the concept of limits. Okay. So differentiation is nothing but some evaluation of limits. Okay. So let us do some example. So are you understanding? Changing y coordinate by changing x coordinate. Changing y coordinate by changing x coordinate. So why it is so? What is your minus h? You are writing like this: a minus h minus a. So a get cancelled, so you are left with minus. Okay. And what is the geometrical point of view? You may write that thing. What do you mean by geometry? Geometrical interpretation of differences. geometrical interpretation, right? F is differentiable at A means F is smooth at A. Smooth means that is there will not be any pointed edge. EPGE. There will not be any pointed edge. Yes. So you may plot this. Suppose I may have this type of graph. Okay. So suppose this is your A. So here the value, the output f of A is here, but you can find that there is no smooth structure. Okay, here there is a pointed edge. So here also, suppose this is your B, so this is your f of B. So the point is B and f of B. So at B, you are not finding a smooth structure. But whenever you are considering C here, so there is a smooth structure. There is a smooth structure. There is no pointed thing. Okay? So I can say that smooth structure exists. So that means in this case, the function will be differentiable at C, but it will not be differentiable at A, and also it will not be differentiable at B. From the geometry, you can guess like this. Okay. Now, so without computation, I can guess whether a function is differentiable at a point or not. Let us consider an example. Let f of x is equal to mod x, and you have to check the differentiability of f at x is equal to 0. From the geometry, I can also guess. Yes, from the geometry, I can guess. So from the geometry, how can I guess? I have to plot this graph. How can I plot this graph? You write y is equal to f of x, that means here it is mod x. Okay, what is its graph? What is its graph? You plot this graph. How we are plotting? You take any value for x and accordingly get the value for y, and you plot. You take negative x, you take positive x, and what type of graph you are getting, just observe. If you are having a pointed edge at 0, then you will say that it will not going to be differentiable x is equal to 0. Okay, to do that, yes, I have filled up the ink in between. Have you completed? What type of image you are getting? Yes.
Yes, sir.
What type of image you are getting? Whether you are getting a pointed shape at x is equal to, so this thing can be written as like this, x and minus x. Okay. So when it will be x, if x is greater than 0, it will be as it is. When x is less than 0, it will be minus x. Okay. So if you are plotting this, when x is equal to more than this, that means in this region, your y is equal to x. So if it is x is 1, y will be 1. If x is equal to 2, y will be 2. Like this. When x is equal to, this is 1, 2, this is 3, suppose 3. When x is equal to 0, it will be 0. So its graph will be like this. Okay? And if you are considering x as x less than 0, so you are here, so its value will be, when you are taking x is equal to minus 1, its value is 1. Because minus of minus 1, it is 1. Whenever you are taking minus 2, this is minus 1, this is minus 2, this is minus 3, like this. If it is minus 2, then minus of minus 2, it is 2. So its value will be 2. So its graph will be like this. Okay? And at 0, you can see that there is a pointed, everybody, there is a pointed. So that's why from the geometry it is clear that pointed means here there is not smoothness at that distance. So that's why this is not differentiable at the function is not going to be differentiable at 0. So I have to test this analytically also. So that means you have to check the LSD other than RSD at 0. So analytically from the geometry, so you can say that from the geometry, as there is a pointed structure for x is equal to 0, therefore f is not smooth at x is equal to 0, or f is not differentiable at x is equal to 0. Okay. Now, how can I prove this analytically? Analytically, what can I say? How can I prove? Analytic proof. In analytic proof, to show RHD. RHD means right hand derivative is not equal to LHD, where at x is equal to 0. So how I am defining RHD? You have to do this at this time. So RHD is equal to limit h tends to 0 f of what? At a 0 you are taking. So a is equal to 0. So 0 plus h minus f of 0 divided by h. You evaluate this limit. And similarly for LSD, you evaluate this limit. H tends to 0, f of 0 minus h minus f of 0 divided by minus h. If these two limits are same, then I can say that LSD is equal to RSD. So that means derivative exists. But here you can see that
ସାର୍ କିଛି ଦେଖା
ସାର୍
ହଉନି।
କିଛି ଦେଖା
which one?
ସାର୍ କିଛି ବି ଦେଖା ହଉନି।
କିଛି ବି ଦେଖା ହଉନି ସर टाइम ही गलानी
Okay. So,
सर डाटा भी उड़ी
so
गलानी
see, this is your homework. Can you evaluate this limit? Whenever you are writing f of 0 plus h,
କିଛି ଦେଖା
क्या
ଯାଉନି।
which one?
सर सर केमती करिबु एज जगह रे वैल्यू पुट करके
Yes, nahi. F, see, yes, f is defined like this. F of 0 plus h. F of 0 plus h means what? Or okay. So here also you can write whenever x is equal to 0.
सर देखा
x is
जाउनी।
equal to
सर देखा जाउनी सर टिके
कि
देखा
वीडियोटा
जाउनी सर वीडियो अरे सर देखा ला
देखा ला
okay. So your f is defined like this. F of x is equal to modulus of x. So if I am writing modulus of x explicitly, its meaning is like this. Okay. Then how can I write this? So you have to use the function f of 0 plus h means what? 0 plus h. So that means it is h is a positive quantity. H is always greater than 0. H is a positive quantity. So that means argument is a positive quantity. So that means your
पॉजिटिव क्वांटिटी
so it will be h. Then f of 0 is 0 divided by h is there h. So that means h get cancelled, its value will be 1. Okay. And for this case, so you write h tends to 0 and f of 0 minus h. So that means a quantity which is less than 0. 0 minus h. H is a positive quantity. So h is a positive quantity. You are moving left to 0. That means you are here in negative axis. Okay. So that means you have to use this quantity. So it will be minus
एच एच
okay. So it will be minus h means minus of minus h. What is that one? Minus of minus h. Isn't it? Your argument is h minus h. So when f of x, its value will be minus x. If it is here you are evaluating f of minus h. So it will be minus of minus h. So this is, and then there is minus h. What will be its value? Minus of minus h is h. So you may write limit h tends to 0 h by minus h. What is its value? So you are evaluating limit h tends to 0 of minus 1. So its value will be minus 1. Okay. So your RSD here is 1, but LSD is computed as minus 1. Yes, is it clear? So that's why you can say that RHD is not equal to LHD or x is equal to 0. Therefore, f is not differentiable at x is equal to 0. Okay. So in this way, we are dealing with the problem on differentiability. Okay. So I will give you some problems. Okay. So I will give you all the problems as material because I have no time. Okay. Try to read this. If you need, I can supply this video also. Okay. Yes.
यस सर
yes
यस
sir
सर
yes sir yes sir yes sir
Okay. Thank you.
सर
all.
वीडियो रिकॉर्डिंग सेंड कर दीजिए
thank you
सर
sir
Okay. Thank you.
okay sir
थैंक यू
thank you sir
थैंक
Take
यू
care all.
सर
सर डाटा सरीगला सर
यू टू सर
डेटा भी सरीगला मोरा
Okay.
नहीं डेटा मोरा सरीगला सर गले कोडे मुझे सरला ना सिमी रोहित
हाँ जे डाटा सरीगला चलो
रोहित କେମିତି ଦିଶୁଛୁ?
Oh my god.